Hello everyone. Today let's solve the problem number 11, right? Container with most water. So what the question states here, we are given an integer array height. You can clearly see here we are given an integer array height of length n. So this is of the this one. We are given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I, 0 and I, height of I. So this one we just have to keep in mind, right? So there are n vertical lines drawn such that two endpoints of the ith line are I, 0 and I, iterated value of the height. This is fine. So we have to find two lines that together with the x-axis form a container. So find two lines that together with the x-axis form a container such that container holds the most water. This is very important. We need to find two lines together with the x-axis that form a container, that is fine, such that the container holds the most water. This is very important, right? So we have to return the maximum amount of water that the container can store. So we need to return maximum amount of water that container can store, right? So they have clearly mentioned that we shouldn't slant the container, or you may not slant the container they have given. Just keep this in mind. We cannot slant the container, right? So let's come to the first example here. Just give me a second here in this case. So we'll be considering the first example as I've said. So this one. So here, first thing, every container means the distance between every container, we are having a width of 1. Just keep this in mind. So every container has a width of 1 here in this case, right? So every container has a width of 1 and area is calculated by width into height. And area is calculated by width into height in this case. So this will be 1, width 1, and this will be width 2, this will be 3, this will be 4, this will be 5, this will be 6, and this will be 7 in this case, right? So every container has a width 1, right? This will be 1, 2, 3, 4, 5, 6, 7. We will be starting from the maximum one, means the height, the length, the line which is having the highest length, right? The line which is having the highest length. Here in this case we have the 8. So the last container here we are having length 7 in this case, right? So for each line, let's calculate the area here. For the first line, this one I'm speaking of, first one when I say this one, we have 6, right? So the width here, the width between this one and this one is this one we have 6. 6 into 1 is nothing but 6 for the first one. And for the second one here, we have to go with this one and this one, right? So this one and this one. So here in this case we have 2, right? 2 into 2 is nothing but 4, right? 2 into 2 is nothing but 4. For the third one we have 2 here in this case. So sorry, just give me a second here. For the third one we have 5 here. This one we are considering. So 5 into 3, width is this one, 3, right? 5, height is 5, height into width or width into height, 5 into 3 is nothing but 15 for the third one. So next one we are considering for the 4. Here in this case we have width 4 as well. 4 into 4 is nothing but 16 in this case. Same thing for this one. Next one we have 8. 8 into 5, width we have 5, length we have in this case 8. 8 into 5 is nothing but 14 in this case. So same goes with the next one. We have 3. 3 into this one, 3 into 6 we have width here 6 we have. 3 into 6 is 21. 3 into 6 is 18 here, not 21. 3 into 6 is 18. The last one is we have 7 with a height of 7 here in this case, or length of 7. Sorry, length 7 here. So 7 into 7, height into width. Height, this is height itself basically. Height into width here in this case, 7 into 7 is 49 in this case. So the maximum area out of all this one, all the numbers that we got here as 49 in this case, right? We have got 6, 4, 15, 16, 40, this one 18 and 49. So out of this, the max one is 49. That's what we need to return as output in this case, right? So that's what we need to return as output. Here also we got 49. So this is how we got 49, right? So that's what we need to return. That's what they have asked in the question as well. We have to find the maximum amount of water that is stored in the container. That's what we need to find out, right? Simple to understand, right? So let's come to the second example. Same thing here. We have only 1 and 1. So the maximum height we have here is 1. The lowest we have is 1 as well. So for 1 and 1, with the height 1, this one, and width is also having 1. 1 into 1 is nothing but 1. Only one vertical line we have. If we calculate the width, it will be 1 into 1, 1 itself. So the output that we have returned here is 1. Simple, right? So you can just visualize in the same way that we did for this one, first one, right? Simple to understand here. This one, 1 into 1 will be quite obviously 1. That itself we need to return because we have only one vertical line here in this case. Means one width between the two vertical lines. So this one will be 1 into 1. Quite obviously, the answer will be 1 itself in this case. Right? I hope this is clear. Simple to understand, right? So first what we will do, I hope the question is completely clear. What we need to do is completely clear as well. First what we will do, we will discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So here, let's discuss the approach step by step. First thing is, we need to note down here as we will be going with the two-pointer approach, or we'll be going with the 2 pointers, right? So we'll be making use of the 2-pointer technique or 2-pointer approach here. The same example, the first example that they have given in the question, I have considered the same example. We have already discussed this one, how we got 49, right? So the width between the each vertical line here is this one, 1, and we have to start from the maximum height, and we need to check for all the means between the vertical lines. We need to check area between each vertical line, and then we need to find out the max, right? In this case, every vertical line here has a width of 1 here. So this will be 1, 2, 3, 4, or this one 5, 6, 7. So we calculated this one. For the last one, we got 7 into width 7, basically 49. Basically, out of all the things, 49 was the max. So we returned 49, right? So that's how we got 49 in this case. So let's discuss the step-by-step execution now. We have already discussed this one. Now we know how we got the output, but let's discuss the coding part, step-by-step execution, right? First, what we'll be doing, as I've said, we will be making use of the 2 pointers here. We will be making use of the 2 pointers. So first, we'll initialize the 2 pointers. L equals 0, the starting one or the leftmost index. R equals n minus 1, the last index or the rightmost index. This is the starting index. I'll just write SI. In this case, this will be the end index. So this one is starting index and this one is end index or the rightmost index. This is leftmost index and the rightmost index. We are making use of 2 pointers, L and R, right? Left and right. So second step, let's move on with the second step. First step was easy. Second step is we have to compute or calculate area at each step. So we have discussed this one logically, but let's do this one step by step, right? So we have to compute or calculate area at each step and update the maximum area. Every time we have to update the maximum area. We have to compute area at each step and we have to update the maximum area each time, right? So we were calculating the area between two vertical lines and we were updating the maximum area each time, right? So that's what, again, we are doing the same thing here on the second step. Formula is, just remember the formula, r minus 1 into minimum of height of L comma height of R. R minus 1 into min of height of L comma height of R. This one you need to remember. In case of while writing the code, this will be very useful. So we need to remember this one. The formula is R minus 1 into min of height of L comma height of R. So compare, let's compare height of L and height of R. Move the pointer that is pointing to the smaller height. So let's compare height of L and height of R. Height of L and height of R is nothing but the left pointer and the right pointer, the left one and the right one. So two vertical lines we are speaking of, right? So when we take the value, so suppose we are taking 1 and 8, just for the example, this will be L and this will be R. That's what we have to compare, these two things, right? So in between this one is we have width 1, that they have given in the question. We have already discussed this one, and we have to calculate the area. So in this case we have 8, right? 8 into 1 will be 8, right? That one we have to compare height of L and height of R and move the pointer pointing to the smaller height. So we have to move the pointer that is pointing to the smaller height. This is very important. So that is the reason we got 7 into 7 49 here in this case. So we didn't consider the height of this one 8. Instead we considered here this one 7. We moved the pointer to the smallest one right here in this case. So I hope this is clear. So let's move on with this calculation part or the final part here. So first, left we had 0, right? We had 8. Left we had 0, right? We have 8. We are considering this one. Left we have 0, right? We have 8 in this case, right? This one I'm speaking of, right? Left we have 0, right? We have 8 in this case, right? So just give me a second here. Yeah, width we are having 8. So minimum height we are having 1. So this one, between this one, minimum height we are having 1 in this case, right? So minimum height we are having 1. Area is 8 here in this case. 8 into 1 is area is height. So now the max area that we got here is 8 in this case. This is fine. So why area is height? 8 into minimum height, this one. Width into minimum height, this one we are considering. So the formula is r minus 1 into min of height of L comma height of R. R minus 1 we have got 8. Min of height of L comma height of R we have to consider, right? Height of L, min height we have already got here. Min of height of L minus this one. Height of L comma height of R 1. So 8 into 1 in this case is 8 max area. Same thing we have to do for all the things here. You can just check it out. Next, left we will be considering 1. For all the things we'll be considering 1. 1 1. We are having the width 1 at each step, right? So left pointer 1 1 1 will be moving 1 1 1 in this case. So right will be 8 7 6 5 4 3 2 in that way. Next way it will be 8 itself. Width will be 7 in this case. Minimum height is 7. 7 into 7 49 we got. Now area is 49. Max area we will update this one 49. So we will check for everything. We'll check for right pointer 7. We got width 6 here. In this case we have minimum height of 3. So 6 into 3 will be 18. So still the max area remains same here 49. Same thing goes with this one. Next step 6 5 8. 5 into 8 is nothing but 40. We calculated from this one, right? If you remember 6 4 15 16, we got this one. We have already calculated this one. I have showed this one, right? Step by step. I have showed you this one already while considering the first example. That's what we are doing here. 5 right pointer and width we have 4 and minimum height we have 4. This one 4 into 4 is 16 and right we have 5. Width we r minus 1 nothing but width we have 3. Minimum height we have got 5 here. 3 into 5 is nothing but 15 in this case. So formula is this one, r minus 1 into min of height of L comma height of R, right? So here in this min height is nothing but min of height of L comma height of R. That's what here. So this one we have got R3, width R minus 1 2 and min height 2. 2 into 2 is nothing but 4 here. 1 into 6 is nothing but 6 here, right? We have 2. So this is fine. So we already have the maximum value 49. So we don't have the value that is greater than 49 each time. You can clearly see here. So 18 we have, 40 we have, 16 we have, 15, 4 and 6. Every time we have got the value that is lesser than 49. That is the reason we are keeping the same value, means 49, which is greater than all the values that we have got in the area, right? 49 49. In the last this one cell we have got 49 itself, right? This we will return this one as output. 49 is the max area that we got. This we will return as output. In this case the final output, the maximum area that is found is 49 so far. We found 49. We know this one, right? So this is the approach that we will be going with. Simple 2-pointer approach, right? So now we are completely familiar with the approach, right? Now we are completely familiar with the approach. So let's discuss the edge cases one by one. So the first edge case here is just give me a second here. The first edge case here is minimum input size. So we are going with the minimum input size n equals to 1 1. We have already discussed this one in the example, I think. Second example, I think. Yeah. We know output that we got here is 1, right? So the first edge case here is minimum input size, that is nothing but n equals 2. And the second edge case here we are going with here is all heights are equal. 5, 5, 5 we have. This one you can just draw the diagram in the same way that I have showed for the example 1, and you can just check it out. You will get the output 30 in this case. So we have 3, 4, 5, 6, 7, right? The maximum we have here in this case is 5. The last one we will be having is 5 itself, height. So width, each width we have this one. So 7 lines if we have 1, 2, 3, 4, 5, 6, 7. So each width we have this one, right? 1, 2, 3, 4, 5, 6 here. The final one we are having the value of 5. 5 into 6, a width equals area equals width into height. This will be 5 into 6, nothing but 30. So that is how we got 30 here on this case, right? So you can consider, or you can try out in the same way that I showed for the example 1 in the approach, if you want to know this one step by step how we got the output. So third one here in this case, one tall line, all others small in this case. 1. So we have this one 1 1 1 50, this one 1 1 1. So basically we'll start with 1 and we'll consider the this one, right? The minimum one. So we have width of 6 here. The last one, the width will be 6, quite obviously, because we have 7 values. And the last one, this one is, height is 1. This one 1 into 6 will be quite obviously 6, the output. That is how we got the output 6 here in this case. So let's come to the decreasing height. Same thing here. So you can consider this one 9, initial height, this one 9. So we have how many this one values? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values, right? So this one will be 8. What do you call? Width will be 8. The last one width will be 8, and 1 into 8 we will get 8 itself as 1 into 8. So the last one line is having the height 1, and width as we have the this one 9 numbers, it will width will be quite obviously 9 minus 1, right? So 9 minus 1, this will be 8. 1 into 8, the output will be 8 in this case, right? So I hope this is completely clear. So this is for the this one case, decreasing height. So these 4 edge cases that we need to keep in mind, right? So the first edge case was for minimum input size. The second edge case was for all heights are equal. The third edge case was for one tall line, all other small. The fourth edge case was for decreasing heights, right? These are the 4 edge cases that we need to keep in mind. So now we are familiar with the approach and we are good with the edge cases as well. So as we are familiar with the edge cases and approach, it will be easier to write the code, right? Now let's start writing the code. So here, step, if you remember, we have to initialize the left pointer, right pointer, as well as the max value. So max value we have to find out every step, right? So that is the reason let's initialize the max to 0. So I'll just consider here L equals 0, the left pointer, R, the rightmost index we have to initialize to. This one will be height dot length of the height minus 1. This is fine. The final one is we have to find the max at every step. So I'll just keep here max equals 0 initialize this one with 0. This is fine. The second step is we have to continue until left hand pointers meet. Basically we have discussed this one in the approach. So this one I'll just make use of the while loop, while L less than R. We have to continue until left pointer is less than right one, right? So we have to continue until left and right pointers basically meet. So we have discussed this one in the basically approach. The formula was this one, R minus 1 comma height equals min of height of L comma height of R, if you remember. The same thing. Let's calculate the area. We have to calculate area between the two vertical line every time, right? So two vertical line every time. That's what we discussed, right? So we need to calculate area here. Width equals R minus L. We know that width equals R minus L here in this case. Height equals min of height of L comma height of R. So I can just write it in this way. So max, this one will be math dot max of max comma formula was R minus L, if you remember, R minus L into math dot min of height of L comma height of R. So this one, we saw this one in the calculation part, I think, right? So we discussed for the every step. For each step, how we got the output, and we updated maximum height at every step. So that's what we saw in the calculation part, right? That's what we are writing the formula. Formula I mentioned in second step, I think. So this one, height of r, height of L comma height of r. This is fine. So the next step here is we have to move the pointer that is pointing to the smaller height. So for that, I'll just make use of the simple if condition here. If height of L, this one, less than height of r, then what we have to do? We have to move the pointer pointing to the smaller height, right? If height of L is less than height of r, then we have to move the left pointer forward. So just give me a second here. This one will be L plus plus. So we are incrementing the left pointer here. Else we have to move the right pointer, right? So I'll just give here else r minus. Nothing but we are moving the right pointer backward. Either we have to move the pointer pointing to the small height, means either we have to move the this one left pointer forward or right pointer backward, right? So this is fine. I hope this is clear. The final part here is we have to return the maximum area that is found. The final cell we considered, if you remember the calculation part, we have to return the maximum area that we found, right? That's what they have asked in the question as well. So I'll just come here. Let me give return max in this case. So this is it for the code. Simple to understand, right? So let me hit the run button. So here you can clearly see the sample test cases are getting passed. Means the code works absolutely correct as of now. Let me hit the submit button. Let's see whether this works for all the test cases or not. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case, right? Let's quickly discuss the complexities for the code that we have written. So first thing here, we need to notice the approach that we went with here is this one, two-pointer technique. We know that one, right? Two-pointer technique or two pointers. So what will be the time complexity here? The overall time complexity would be big of n. So overall time complexity would be big of n. And what would be the space complexity here? The overall space complexity would be big of 1. Why the space complexity here is big of 1? Because we don't need any extra space, right? So no extra space is being used here apart from the few integer variables here. Apart from the few integer variables, we don't need any extra space. That is the reason we have got the space complexity big of 1. So what is so why the time complexity is big of n here? So we are making use of the two pointers, right? We know that, and each pointer moves at most n times. We know that, right? Each pointer moves at most n times. This will lead to the linear time complexity, nothing but big of n, right? So overall time complexity is big of n, and the space complexity is big of 1 in this case, right? I hope this is clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.